Thank you, everyone, and thank you, Adrian, for the introduction. While I was discussing with Lavinia, I'm not sure if I'm hearing myself well. Okay, good. While I was discussing with Lavinia about the topic that we wanted to introduce in this conference, I was also thinking about starting a little bit to give the context on where we started and how we reached this point in time. So when I was a recent hire in Voice, in Vodafone Intelligent Solution, I have received this message from my line manager, and that was saying, the future starts today, not tomorrow. Of course, he did not say it first. Pope Paul II was the first one to say it, but I think what he really meant at that point in time is that the organization was just at the beginning. I have been around the 50th employee in the company, and we were trying to build up something bigger here in Romania, right? So just to take a look on what it has been. 2016 is the earliest photo that I have found, and I was recently appointed team leader for a team which was having DBAs, so database engineers, compute engineers, and storage engineers. We were having a lot of customers, so just for you to know, Voice, Vodafone Intelligence Solution, it's actually delivering digital services for Vodafone customers. So our customer, it's Vodafone, and it may be Vodafone Romania, Vodafone Germany, Vodafone UK, Italy, and so on and so forth. So our customers were actually asking for infrastructure. Myself, I am a former database engineer, as I was saying, Oracle Technologies, and I was trying to reach a way that I have an end to this process. As a shared service center, as a newly created shared service center, our scope was to deliver not only the technical work, but also deliver efficiencies for the company. So after these things were happening, all of them on the list, with more than 10 teams, which were actually interconnected and intertwined, we were going to the data center to provision the infrastructure. We are actually starting from a moment where every customer was delivering in its own data center, Vodafone Romania in the 3 locations in Romania, Germany in its location in Germany, and so on and so forth. What that meant is that you needed to pay attention to where you were delivering your infrastructure, because every customer had different kind of standards. So just to give you a glimpse on how it looked like, well, it was for sure FIFO, right? First in, first out. I was having a small team, but I was depending on all other teams, which were actually taking some time to deliver their tasks. So we were working on a ticketing system, and just to make an idea, if you were to have a server, a physical server, where you would have a database on top of it, where you would install your application, it will take around 6 to 9 weeks. So this is the context that we started from, and now I'm going to give it forward to Tudor to show you the current state.
Yeah, so the first thing that I would like to do is to set up the context a little bit on how let's say, the cloud platforms look like in Vodafone. And we can split the platforms into 2, into the private and the public cloud. So at the start, we had some VMware data centers installed into some geostrategic locations, let's say, in Milan, Rotterdam, and Dublin, spread across Europe. And afterwards, we start adopting the public cloud. We start migrating applications from the private cloud to the public cloud, into the AWS, Google Cloud, Azure, and recently into the Oracle Cloud. Now, a nice thing that appeared recently, it's Oracle Cloud on-prem. So they're bringing up public cloud services on the on-prem infrastructure. So you have access to the public cloud services that are available, let's say, in the public cloud, but you can install that region inside your data centers. So you have all of the cloud services that are available in the public cloud in your on-prem infrastructure. And that was a nice thing for the application that, let's say, did not have the data clearance to go to the public cloud, and also they wanted to consume some public cloud services, and that was a nice thing for us. Afterwards, how the migration looked like, and we started, let's say, 1 year ago, let's say, migrating from the VMware data centers to the Oracle Cloud infrastructure on the on-prem side. I'm managing that part of the cloud infrastructure. Also, we have the public cloud ones, but again, I will be speaking about the migration. So we had like 800 more or less cloud infrastructure clients that wants to be migrated from the on-prem infrastructure to the Oracle on-prem public cloud, let's say. The clients are spread across 10 local markets, Vodafone Germany, Italy, and so on and so forth, and more than around 6,000 infrastructure assets to be migrated from the on-prem infrastructure to the public cloud infrastructure. So a lot of things to be migrated. It felt like in the spring when your battle half wants to do the spring cleanup, and you want to clean up an environment or you want to move things from one closet to another. So yeah, we discover a lot of things. How big data it's looking right now in Vodafone? So we have some, let's say, streams that are focused on the cost optimization, in the network optimization, in the marketing and sales, and the Internet of Things. For example, in the Internet of Things, we have the partnership with BMW, where we're collecting data from the cars, the network, and so on and so forth. We try to optimize the network connectivity based on the data that we're collecting from the relays. Let's say cost optimization was a big part. As a cloud infrastructure team, we're providing data for the, let's say, teams that are ingesting the data, try to analyze them, and to make cost optimizations at the level of the data center. Also, yeah, marketing and sales, a lot of data, it's fetched there and used to create campaigns and so on and so forth. So we have some projects that are deeply interested in the big data and the services that the public cloud might provide to them. Again, why moving to the public cloud? We're speaking about scalability, the cost efficiency, the flexibility that we have on the cloud, and also for those teams, the analytics and the AI platforms that those public clouds are providing. Now, as I said, in the private cloud, we had a lot of infrastructure assets. They were scared across, let's say, 3 or 4 data centers. Whenever Vodafone's bought a new location into in Europe, they also inherited the infrastructure for those local markets. So you can see that there are a lot of infrastructure assets spread across a lot of data centers. They were not standardized. They were not consolidated in any way. So we felt like that migrating some applications from the private cloud to the public was the perfect spot in the time where we can do some enhancements. So we started standardizing the things. We have a portfolio of tools that we're using for all the projects. We try to not deviate too much from that. They're approved by security, and we tend to use those as much as we can. And yeah, not to have 1,000 tools for a single thing that we want to do. Also, the consolidation, we try to reuse the tools that are already in place for projects, so we'll not have, I don't know, 100 Jenkins instances for 100 different projects, because you can put the Jenkins instance wherever you want. We tried, for example, a very interesting stream was the DevOps Factory that took a lot of projects and tried to consolidate the DevOps side of those. So instead of having 100 DevOps teams or streams, to have only just one that it's providing services to multiple projects. And what is the better way to achieve standardization and consolidation than using automation? So we try to make up some standard processes and also to put up in place some applications that will, let's say, commission the infrastructure for different projects. Now, I will not speak about any specific cloud provider. I will make an, let's say, analogy of the public and the private cloud that we're having. We're seeing them as gardens. In the private cloud, you can have your own tomatoes, your own apples. You can do whatever you want to do with them. It's your garden. You know how secured you want it to have. And also you have the public cloud. It's like going to the local market where you have a lot of exotic spices, maybe some seafood, and so on and so forth. And also some costs associated with that. And the main thing is that we are feeling like we are some chefs that needs to prepare a, let's say, a dinner for someone that has a strict budget, that will be the client, and we want to provide them the best meal that he can have for that money, even using the things that we have in our own garden or going to the public, to the local market to fetch some, I don't know, exotic spices or seafood. And we come up with the infrastructure factory. So the infrastructure factory does exactly what a factory will do. It tries to standardize the way that infrastructure is provisioned. It doesn't matter to which public cloud you want to hit or private cloud you want to hit. The customer will complete in a self-service portal the requirements that he needs to have for the infrastructure. The factory ingests the request of the customer that we're having, and it tries to provide the services that he needs in one of the public clouds. It looks like having a lot of Lego bricks, and whenever the customer comes and say, okay, I want to build a machine with the Lego bricks, we build a machine. If you want to build an airplane with the Lego bricks, we build an airplane with the Lego bricks. It depends a lot of what the customer needs. It can hit different cloud providers based on the needs that it's having. Now, the factory is split it up in domains, and we tend to feel it like natural. It's like the domain-driven design. We want to split the factory into domains where every domain has its own spoke, and the process is, let's say, tailored to go through all of the domains to be approved. For example, a new service that will be broadly available in Vodafone, it will go firstly into the core domain, it will get approved, and afterwards it will move to the security to get assessed by the security, to the provisioning team to prepare the blueprints in Terraform that will provision the infrastructure, that service. It will go to operational, for example, to the design team, to the cost team, and so on and so forth. So that service, whenever we want to enable it to the customers in Vodafone to consume it, we are going through all of the domains here, just to make sure that that service is covered end-to-end, it's in its own life cycle. Now, traditional versus factory approach. Into the traditional approach, like Alina said at the start of the presentation, we had a lot of manual steps. A lot of time was lost in the process because, yeah, the things were not automated. Everybody needs to know the process. You have to put it on paper. There were a lot of inconsistencies in the infrastructure because, again, you can hit up a data center in the Czech Republic, you can hit a data center into Rotterdam, into Dublin, and so on and so forth. And they were not standardized as units. You don't have an automation and an orchestration layer on top of those to control how the resources are being created in those data centers. And going with the factory approach, again, the same things that I'm saying previously, it gives us the advantage of controlling how the public cloud resources are created, the on-prem resources are created, how the connectivity is implemented between the public clouds and the private clouds. So it gives us a lot of advantages there. And if I'm going to the factory's first version and how we achieved that, we started firstly with the Jenkins and the Terraform. And we created configuration files in the Terraform, exposed those blueprints through the Jenkins to provision certain pieces of infrastructure in different cloud providers. And afterwards, we felt the need of putting an orchestrator out of Jenkins that will understand the business logic that is coming from the customer. It will digest the business logic, and it will make a certain, let's say, set of steps to accomplish the architecture that the customer wants. Also, the approach with building up an API on top of the Jenkins and an orchestrator, let's say, it was that we can connect that infrastructure provisioning to the third-party applications that are running inside Vodafone. So what that does mean, so we are handling the pre-provisioning and the post-provisioning things that needs to happen to a service or to a database or a compute instance and so on and so forth. Whenever a compute instance is created, it needs to be documented in a CMDB. Whenever a new, let's say, piece of cloud is provisioned for a customer, it needs to go to the FinOps application inside Vodafone. Whenever a new subnet needs to be provisioned in one of the public clouds because we need to have the control on how the subnets are allocated, they are going through the IPAM API, and we provision one of the subnets based on the configuration that IPAM has in behind. And how the customer environment setup looks like. So we have two kinds of customers. The customers that knows what they want, and they can go a little bit self-manage, and we are just creating them in the public cloud, some envelopes. And the envelopes ensures that they cannot over-provision, they cannot provision services that they should not have access to, and also they don't have the access to create connectivities outside of the public cloud to whatever. So we are trying to create them the envelopes that assure them the access by creating the groups, for the groups to create the policies, so they have access to certain services that are approved by the security teams. We also create them for them the connectivity. When they need connectivity, for example, from the public cloud to the on-prem data centers, we try to create the connectivity as the environment is created. And also, we are enforcing some quotas at the level of the slice of the cloud that they're receiving, so they do not over-provisioning. So we are controlling also, by that we are controlling the cost a project can generate. The nice thing is that the InfraFactory API, it's also controlling and it's keeping track of where the project has a piece of cloud. So if a project is spread across multiple cloud providers, we are controlling the cost overall. So if we are saying that a project inside Vodafone needs to, let's say, a cost of 10k euros per year, we are controlling that across all of the cloud providers. So we are making sure that they're generating a 10k euro cost across all the cloud providers that we're having. Afterwards, some challenges that we faced from our experience. Firstly, there were the security concerns, and there were a lot, because again, working with some very sensitive data, as Vodafone is working with, there were a lot of questions asked, okay, you want to go with this data into the public cloud. Maybe it's not a good idea, but afterwards, after we speak with them and we do an assessment on how the public cloud is working and the security level in the public cloud, they were okay with that. They said, okay, if we are controlling the flow on how the services are provisioned inside the public clouds, you can go forward with it. The complex initial setup, as you saw, we had to develop some APIs, some microservices, let's say, that will control how the services are spawned up in the infrastructure. And that was a challenge. A lot of developers, a lot of code has been created there to manage the, let's say, the provisioning, the update, and the deletion of the resources that are created across multiple public cloud providers and private cloud providers. It was a steep learning curve, so we had to teach our engineers, network engineers, compute engineers, database engineers, that they're not managing directly a resource from the console. They should start managing it from, let's say, Terraform and Ansible, how to configure that, what is infrastructure as code, how you can do operational things on top of the infrastructure as code, and so on and so forth. So it was a learning curve for them as well. The potential resistance to change, having the things standardized and consistent is a nice thing, but again, it can present a very strong resistance to change, because again, if a customer comes up with an exception and says, okay, but in the old way, we had a lot of exceptions and no one said anything, well, right now it's not possible anymore. You need to be, let's say, aligned, and maybe we can remove the exception that we're having, finding an alternative. So also help us doing the cleanup inside the infrastructure. Afterwards, it was the drift management, and the drift management, it's a very big thing. Once you start putting tools like Ansible, like Terraform mostly, and creating a state for the infrastructure that you're having, once the operational teams do things like, okay, I will go to the console and fix the database and creating the drifts, you need to find a way to control the drift and how you reconciliated the state of the infrastructure with the state that you're persisting inside the Terraform state files. We are still working on that. We are trying to put the reconciliation pattern in place. The services try to scan the infrastructure to raise up the exceptions that are appearing between the state that we're having in the Terraform states that provision the infrastructure and the real infrastructure. Afterwards, the automatic reconciliation of the resources, it's more or less and more advanced pattern, but we are trying to reach that. Firstly, we are focused on detecting the drift and teaching the operational teams that, okay, once the infrastructure is provisioned with a tool like Terraform, do not touch it directly using the console. We had also less flexibility for bespoke needs. Again, we try to educate our customers that whenever they're coming with an architecture that they want to implement, they need let's say, an infrastructure architecture for the applications that they're developing. They need to understand that, okay, we need to have it documented. We need to make sure that we understand what you need from the infrastructure, and also we have all the Lego bricks that we need to achieve the architecture that you need. And that was a big thing because everybody started to say, okay, but it's a lot easier for me to go directly to the private cloud and provision whatever I want. Well, yeah, you can go directly and provision it, but again, it will be a lot easier to provide you the support that you need for the infrastructure where you are hosting your application if the things are deployed in a certain manner and they are looking the same across all of the environments. Because again, once the operational team kicks in and they need to debug the infrastructure, if something happens with the infrastructure, it's a lot easier when the things are consistent across all the public cloud providers and also to the private cloud provider. So that is it from my presentation. I want to thank you for your attention, and I'm open up to, I think we have a lot more time for the Q&A, if you have any questions. Yeah.
Thank you. Let's give him some applauses. So, questions? Great.
Ok. Legat de cost, ai spus că ok, poți să le oferi, nu știu, 10K pe an. Cum cuantifici costul? Le dai un cost preconfigurat pentru fiecare resursă sau mergi pe API pentru fiecare? Nu-mi dau seama exact aici.
Ne uităm istoric la costurile pe care le-au generat. Înainte ca infrastructura să fie provizionată la nivel de public cloud, avem o echipă care face, să-i spunem așa, design-ul și se uită la costurile istorice pe care le-au generat alte proiecte asemănătoare cu proiectul care vine să fie onboardat într-un public cloud provider. Deci clientul meu direct, and customer-ul meu direct, nu este neapărat clientul, proiectul, este integration engineer-ul care preia requirement-urile de la end customer, înțelege exact ce arhitectură vrea să obțină și vine și face request-ul către platforma mea. Și platforma mea, ok, bun, în funcție de ce a reieșit din evaluarea pe care a făcut-o integration engineer-ul, începe să provizioneze bucățile de infrastructură de care are nevoie acel proiect. Deci cumva partea asta de, cum să-i spun, recomandare sau de assessment arhitectural nu e încă implementată în interiorul aplicației. Ar fi foarte mișto să avem și chestia asta, ok, când vine end customer-ul să vadă de la început ce cost îi va fi generat, cumva ne uităm la niște margini în care poate să lucreze proiectul. Să-i spunem 10K maxim pe an, ok, ne uităm peste toate public cloud provider-urile unde acel proiect are provizionate resurse și ne uităm la finalul anului. Ok, a generat 11K cost. Hai să vedem exact de ce s-a întâmplat chestia asta, hai să ne uităm în ce cloud-uri are provizionat acest proiect servicii și încercăm cumva să balansăm costurile. Asta nu e o chestie ușor automatizabilă, să-i spunem așa, dar cumva poate să prevină. Dar iarăși, la nivel individual de cloud putem să setăm și cote de cost. Adică, ok, dacă mă duc în GCP, pot să selectez, poate să genereze maxim 2,5K pe an. Sau la 2K pe an să-mi ridice alerte. Nu știu, în 3 luni de zile se va depăși costul estimat. Și atunci putem să împărțim bugetul ăsta de 10K între cloud provider. Poate are o bucată de infrastructură în AWS, o bucată de infrastructură în GCP. Ok, 2,5 în GCP, 7,5 în AWS. Atunci putem să balansăm costurile astea și să le trecuim.
Mulțumesc.
Thank you. I'll come back to English after this short Romanian
Yeah, sorry.
discussion. Any other questions? Two hands here, so we have the lady. Thank you.
Hi, thank you. So my question would be, if it's clear for me now, you said that you do on-prem, the storage, and then you have the rest of the services like ingestion and compute in the cloud, or?
We can do the following. For example, we can have in the VMware data centers the databases that are consuming a lot of storage, right? And we can connect those databases in the VMware site with the services that are present in the, for example, AWS, right? That are doing the ingestion of the data. So we can keep the data with the big load of data inside the private data centers and expose those to the public cloud and use only the services in the public cloud and connecting them to the on-prem databases. So again, it was like we cannot move the data from the on-prem, but we can connect the on-prem data that needs to stay in the data centers to the public cloud services in AWS. So we're doing a mix-up of things there.
And one...
Cost and security, because again we have 3 big data centers inside in Europe, and moving the data to the public cloud was something that the security was not happy about, let's say, for some kind of applications.
And we had another hand there, and it's going to be the final question.
Was interesting that you said that at some point you will share the information between the cloud providers. I don't know, this is a little bit mixed up. So let's say you put the DynamoDB, let's say in AWS, and you put the ASIC2 in another in Azure or something like this. I mean, yeah, you say sounds nice words, but as a cloud architect, it's really hard to do this, and it's not so feasible, let's say.
I know, we try to keep the projects in a public cloud as much as we can. Let's say the first iteration of the product is to connect the on-prem infrastructure with the public cloud providers. It's not much more about, okay, joining multiple cloud providers and doing multiple services between them. It's about enabling some services that you can only find in the public clouds with the on-prem things that we have that are private, let's say, and it's hard to move that data to the public cloud. Yeah, I can understand that having one service in GCP, one service in AWS can become a real mess really quick. We try to not, and we also try not to do that, but to offer the services that we're having in the public cloud in conjunction with the things that we have in the private cloud. That is the main idea of the product at the time.
Okay, thank you so much.